the signal? Okay, we are live. Okay, so good afternoon once again. Good afternoon, everybody. Welcome to today's live stream. Please, if you're watching us live on YouTube, I will appreciate if you can say hi. I know drop your location and where you are currently viewing from. Hi, Ifeoluwa, how you doing?
Hi, Hedy Young. I'm doing good. I'm fine. Hope you're well.
Yes, I am doing fine as well.
Yeah, good to hear.
Okay, so welcome everyone. Sorry, please give me a minute. My screen, how is it from your end? Is it straight or is it vertical?
I think it's kind of horizontal. Yeah.
Like, okay. Let me correct that. How is it
Okay.
now?
It's well. Yeah, it's good. Yeah.
Oh, okay, so we are going to begin. So, hello everyone, good afternoon. Welcome to today's live stream. I am Edidio Francis and I'll be your host for today's session. Our speaker is here with us, Ifeoluwa Obayemi, and she will be speaking to us on the topic building design and bridging design and engineering, building systems that are user-centered and scalable. Hello, Ifeoluwa, please, you have the floor. You can go on with the session.
Okay. Hello everyone. I think before I proceed, let me quickly share my screen. I mean, so 1 second, please. You can please indicate if you can see my screen. I mean, just let me know when you can see my screen.
I can see your screen.
Okay, perfect. Okay. Hello, everyone. Thank you so much, Ididong, for having me. My name is Ifeoluwa Obayemi, and I'm a software engineer with a strong focus on product and system design. I work at the intersection of design and engineering, majorly building backend systems, developing APIs and architectures that directly shape user experience. So today I want to talk about something we don't discuss enough, not just about design, not and not engineering basically, but how both engineering and design can work together to build products that truly scale and still feel great to use. Uh, so here's what I will cover today. Firstly, we'll talk about the collaboration challenges between design and engineering, why working silos can slow things down. Then we'll look at practical strategies for building better collaboration. After that, we'll explore scalable systems, how to grow products without breaking user experience. And finally, I'll share some key takeaways you can implement immediately within your teams rather. Uh, so let's start with the reality most teams basically face. Sometimes, as a team, when we work at it as a team, design can work separately and engineering work separately, right? And they only meet during hands off. That can create problems like endless revision, wasted effort, and longer timelines. What do I mean by that? Designers basically discover technical limits late, and engineers can also discover missing requirements late, and everyone can now end up networking the same thing twice. I personally worked on a feature where we designed the same flow multiple times simply because engineering constraints weren't discussed early enough. And I'm sure most of us or some of us have actually encountered that too. Um, so this usually happened because of the old waterfall approach we constantly use in our team, where we come from the requirement stage to the design stage, then down to engineering, then also down to testing, right? So each hands-off becomes a failure point. Every time every time work changes hands, like every time we move from um, requirements to design to engineering to testing, sometimes context can be lost. And when context is lost, assumptions usually fill the gap. So when team operates in silos that way, the impact is always clear. Sometimes project takes longer, morale drops, and the products can also suffer. So because of this um, silos work, we can build together, and teams can react to each other that way. Um, so what's the solution now to that challenge that teams usually face? It's actually simple and it's also powerful. So first, we need to stop thinking in terms of design team and engineering team. So we need to think in terms of one product team, because at the end of the day, users don't really care about who designed or who coded the products. They just care about if it works, right? And the designer is planning. A designer is in a planning meeting, right? Is not basically defending design, and we do it this way such that designer does not defend design, and engineers does not defend code. So we are solving a problem together as one product. When designers can where designers can stand is that they understand users needs, and for engineers, which are the developers, we basically do understand technical constraints mostly. So when both perspectives are involved early, decisions become smarter and faster, right? So to make this work, um, alignment is critical. That means early involvement, where we bring both sides into discovery from day one, and we have shared vision. We define what success looks like together. Also, we can also use systems and processes where we design systems, we use documentations, integrated tools, right? And we can also use feedback culture where we speak in outcomes just and not just opinions, right? So um, now let's move to the practical strategies that we can use for seamless collaboration. So one small thing that causes big confusion is sometimes it's language, where designers can say Euro section, and we engineers we usually say banner, right? Designers too, they can say when it comes to probably all these heights and all that, designers can say above the fold, and we will say viewport height. As probably a front end engineer that is working on a design, it would say viewport height. And they're also same thing, right? But just different words. So this can sometimes create subtle frictions between the team. So the solution here is we need to have shared systems. One of it is style guides. Style guides can be both visual and technical at the same time. So so that designers and engineers can refer to it, and we have one terminology for all components. And also we need to have component libraries, right, where there can be reusable pieces with unified namings, where we can, pull from the same library of previewed components. And also, we need to have design systems where we can connect what things look like with how they work, right? So this is just like a single sort of truth for both the design and also the code. Um, So here is a common mistake teams bring developers in. Um, Here's a common mistake that developers that team make rather. So here is it. When team bring developers into a design, you know, it's always probably after they've designed the after design phase, right? I'm talking about designers now, when they've already designed it to the final design, then they will not just bring developers in. So by then it's too late, right? So, and this can also cause a lot of, constraint, like when you want to make changes, it's always expensive. And there are some technical constraints that also surface late, and it can also stretch timelines. So instead of bringing engineers into the final design, it's always okay to bring engineers into the wireframe reviews, where we can have common common approach to the design phase. Because engineers can see the design now, and we can say that, okay, the layouts won't work well on, probably we see the design now, we'll be like, this layout might not actually work on mobile. You might not see that way as a designer, but we can see that way, right? And you can also see that, okay, this feature that is in place now might need an API change, right? Probably it's an existing solution. You might say, okay, this I might need a change. And engineers can also say that there's a simpler way to also achieve it, rather than spending so much time having to design, right? So having a 30 minute early review, doing wireframe reviews involving developers early, can actually prevent more weeks of refactoring. So that way, that collaboration, it helps, by involving developers early into the design phase. Um, another major issue I discover is assumption, where designers assume that developers understand animations and interactions from static screens. Um, that assumption sometimes is risky, right? Assumptions like developers assume the mockups show every state, probably loading, error, empty states, right? Um, so what we need to do in that case is, first, we need to prototype early. We need to have clickable mockups where it can validate user journey, identify missing states, align on interactions, and also we need to have clear flows, right? So it's always cheaper to fix an idea than to actually refactor the code. So instead of assuming that um, the mockups will show every state, or assuming that this is going to load properly, or probably some errors are actually going to the designers have handled some error screens, right? We need to designers need to prototype all those things early, and before handing it off to the developer, all those things need to really be in place, because it's always cheaper to fix that all those things than to try to refactor the code, allow engineers to refactor the code over and over and over again. um so now let's talk about scalability. I'm actually very, very keen on this particular part of the session. So many people think that scaling or scalability is purely technical, and that's not true. Um, because it's not purely technical, though it is, but then it's not just purely technical. Why did I say that? Because scalability is actually, do you know scalability is actually a design issue too? Because when systems slow down, when there is slow time response or loading of screens, or if the system actually break, right, users will feel it, and they will see that they might say that there is slow performance um, in the product, and most times it will feel like bad design to them. And also, if there's any error on the screen, most times it will also feel like bad design to them. I'm talking in the user's side of things now. So most times, if there is downtime also on the system, it also feels like bad design. So now users don't separate UX now from backend. They don't separate the UI experience, the UX, which is the user experience. They don't separate it now from the backend. They see the experience now as one product, right? So when we build systems that grow, we have few principles we need to consider that actually help in a large scale, that help tremendously. And one of it is modularity. I think I'll be talking on this with a very few points bit by bit. One of this is modularity. So modularity is where we break systems into independent components, right? Um, Another one is loose coupling. Loose coupling is connecting through APIs instead of some tight dependencies. Another one is also stateless design. Stateless design is whereby we can allow any server and do any requests, right? Another one is fault tolerance, where one failure does not actually break everything, whereby in that case, there's some technicalities that we need to put in place, right? Where there are retries, the circuit breakers, there are graceful degradations, and so on and so forth. So all these are not just engineering, buzzwords, because I've been using technicalities. This actually protects the user experience as your product skill. As product skill, users experience are protected with all these principles. So performance must be intentional. We need to add caching for frequent requests. We need to move every processes to background jobs. Also, we need to index our databases. So these decisions might not be visible to users, but the impact is not. These decisions might be invisible rather to users, but the impact is not, because users will see all those loopholes and they will cache it, right? But once those things are actually in place with these principles, trust me, they will see that these principles are in place, and it will be very visible to them that, oh, they are having a good user experience as time goes on. So scalability is something that you don't have to, take lightly, because it helps in the long run. It helps the product so much. So teams constantly face trade-offs. Um, so trade-offs like we need to ship new features quickly or address technical debt, but there's no UX debt, right? So we are confusing navigation now. We are also having a consistent pattern. So both forms of debt slows things down. So the goal is actually balance, where we have technical debts and some UX debts. So we need balance. So we need to be flexible on scope, and also firm on our outcomes. And most importantly, we need to prioritize the relationship um, of we need to prioritize relationship over being, right at all times. So I I usually will not really hammer on this trade-off balance, because if there are, let me just give an example. Most times if there are new features coming up, right? Um, there are also some things that we need to really address too for technical debt. So most times we actually confuse a lot of navigation. If you are in the engineering team so well, you understand what I'm trying to talk about, right? Because most times there are a lot of technical debt as compared to UX debt. So if both forms of debt, um, is if UX debt and technical debt is available in that case of trying to, do a lot of trade-offs, it can actually slow the team down. So we need to find balance for the UX and the technical team So that is why collaboration is actually still very much important. From the very beginning, when I talk about collaboration, making the two team as a product team, it's very, very important, because if there's no collaboration, there's no how we can be flexible on scope. So we have to be flexible on scope and also firm on our outcomes for each team. So most importantly, like I said, we just have to prioritize the relationship over being right for some trade-offs. um I don't want to really talk too much, so I'll just leave you all with three key principles from all I've been saying. So first, you need to work as one unified team. That is the engineering team and the product team. We need to work with shared goals. And secondly, we need to create shared language and involve engineers early. I'm talking to designers now. Try to involve engineers early or in your wireframe reviews, right? So we can know what needs to be done and what needs to be in place. With that kind of 30 minutes conversation or 20 minutes conversation, you're trying to see the wireframe review, wireframe, and that review helps even designers to actualize some certain things before you now have your final design as product to the engineering team, right? So third, the design systems that scale. You need to design systems that scale. Those systems that scale, you need to design them from day one. Like from the very um from the very moment that a PR is being given out, right? You need to start designing the system as to how you need it to scale. From the very beginning, you start designing. Like, you don't have to design everything finish before you now be like, oh, I need to start looking at the scalability of that product. Like I said, those principles are involved in scaling. And if you are not thinking as just to a design team, like, okay, I'm working silo as a designer. If you're not thinking that way, there's some things you have to, consider while designing for scalability, right? I mentioned them earlier also. So because great products are not built by design alone or engineering alone, they are built with, both collaboration efforts with intentionality. So we need to, you need to also, put that into consideration and try to design the system that scale from the very beginning of the design phase and not when you are done properly. So I think I'll just land my plane here. So thank you so much for your time. I hope this session actually gave you the practical insight into how the design um, and engineering can actually truly work together to build user-centered and scalable systems, right? So I would love to hear your thoughts and questions after now.
Thank you so much, Ifeoluwa. I really appreciate it. And I too, as a designer, I have also learned a lot, working with software engineers in designing products and building them to scale. I've come to understand the importance of thinking together as a team, not just as different teams entirely, and the importance of having the documentations ready, the style guide, the component library, all those things, they are very important in working together. Thank you so much for the takeaways that you have dropped in the session. Okay, so we have questions from the attendees. I am going to ask you the question. It is, what approach should we use in learning software engineering effectively? Please, what approach?
Sorry, if I hear the question correctly, rather, you said, what approach can you use in learning software engineering effectively, right?
Yes, let's use it for beginners,
Okay,
especially for beginners that want to learn software engineering. What approach can they take to learn it?
okay. Um, that question is actually a very good question, right? And before I even recommend approaches to learning software engineering, I would say that Software engineering is not just about writing code. I want you to know that, because it is now about, in fact, it has always been about not writing code. So it's about solving problems systematically, right? So now I would recommend some approaches that I feel that a beginner can, use as a noun to, learn software engineering. Firstly, you need to build strong fundamentals. What do I mean by fundamentals? You need to understand how programming actually works. You need to learn variables, you need to learn data structures and algorithms. You need to know how the internet truly works, how APIs works, right? And you don't even need to be a mastery immediately. You don't need to know everything yet. You just need a clarity into how all these things, actually work. You just need some, understanding and knowledge, basically. And secondly, you need to learn by building real world projects. So tutorials are not enough. I would say that if you are the kind of person that you watch YouTube tutorials or you check videos online, they are not enough for you to learn. You need to actually build something, at least solve a problem yourself. Think of something. You can even start off by thinking of something and building a basic mobile app from it, right? That's after you learning all those basic fundamentals. Try to build something, try to build a project, and that will help you to learn faster. If you build one project, you will be shocked that you will cover virtually um, more than half of what you need to know, right, as a software engineer, because you would go into struggling with the problem. So you will learn a lot of things. You will learn error handling. You even learn scalability in that process. You will learn structures. You will learn architecture. You will use all these things that you've learned as a fundamental process. You will use it by, just like, practicalizing what you've known by building something. And next, which is the third, I think I mentioned two. Okay, yeah, this is the third one now. You need to try to understand the system itself. So don't just learn syntax while learning. Don't learn syntax alone. It is not enough. You need to understand the system. Like I talked about scalability, you need to understand how a system scale. Okay, think of it like, okay, if somebody is using this my product that I just built now as my project, if we have 100 users using it now, what do I need to do if 10,000 users join the product? That is you thinking at scale, right? Then you have to think also that, okay, what happens if it fails? If this thing fails, what happens if this success rate fails? What happens if this does not, work this way? So you are thinking at scale, you are understanding this, you are understanding systems and not syntax and not just the code, right? So this is where you will move at the start. This is where you move from just being a normal coder, right, to being a software engineer. Software engineers don't just code. Software engineers, think, or we think through the systems. We think through how the system is being built, right? And we also design at scale. So fourthly, I would like you to also have a collaboration mindset. So you learn how to work with designers, learn how to work with other developers. And I would advise for you to be able to learn this, you have to try to contribute to open source projects, right? That would help you to, learn collaboration, because software engineering is actually a team sport. You have to know how to collaborate. You are not just the only one doing writing code. You have to collaborate with designers, collaborate with other developers too, right? And I think I'll talk about this as the last one. You have to be consistent. If you are learning software engineering, effectively means being consistent. So you have to be consistent. You have to create, a daily strategy for yourself, even if it is weekly, you want to do it, but make sure you are consistent, and let that help you as moving forward. Motivate yourself, be consistent, do all that. So I think I've covered most of it. I have a roadmap I created for software engineering 2026. I think I will just share that with Edith Young if she can just push that to the the person that asked this question. I hope I've been able to answer your question. Yeah.
Yes, thank you so much. So, in order for you to learn software engineering, firstly, you need to be consistent. You also need to contribute to projects as well. And you can also try working on projects with the little knowledge that you have. So that is some of the takeaways. Thank you so much, Ifeoluwa. Okay, also there is another question, but this question is directed to me. The person asks, in a dispensation, we are currently where AI gets to build interfaces and using research team patterns that work. What would your advice be to someone who is eager to learn UI UX? So let me just answer that question because the question is for me. So for those in the audience that don't really get the question, what the question is all about is now that AI is capable of, designing user interfaces and also working with data from the research team. So what guidance can I give to someone who wants to learn UI UX today? So my response is that although AI can design interfaces and analyze on research from research results, learning UI UX is still very valuable even in 2026. Because as a UI UX designer, you're going to grow faster in the field if you're able to understand users, solve real problems, and think like a designer, not just to design UI screens. So AI can design screens, but AI cannot develop empathy for users. AI cannot think as a human, and that is where you come in as a UI UX designer. So in order for you to grow in the field, I would recommend that you first of all understand how to work with your users, understand their problems, and then think and solve real life problems, not just to design the UI screens. Another thing is that although AI can design screens, you as a designer, you can choose which screens to share with your users. So you need to really understand what your users want, and from there choose the screens that will solve their problems. So that's my response to that question. Okay. Ifeoluwa, thank you so much for coming on board today to, train
Yeah.
us on how engineering and design things can work together. For now, there are no other questions from the audience, and I really appreciate you for your time.
Yeah. Thank you so much for having me. I do appreciate that.
Okay, so I would really appreciate it. Yes, you're welcome. Thank you for accepting my invitation to be a speaker. Thank you so much. Okay, so thank you all for joining today's live stream. Please, I really appreciate if you can drop some lessons that you have learned from today's speaker and the session as well on your LinkedIn, your X, and share what you have learned today. Building in public is one way of growing in as an engineer and also as a designer. So thank you so much everyone for joining the live stream. Goodbye. See you all in the next live stream. Thank you, Ifeoluwa.
All right.
Goodbye.
Thank you, everyone. All right. Goodbye.